All right, this is the Feb 9 meeting of Kate Scale. Recording is on. Talk amongst yourselves.
So we found a super nasty bug. And the reason it's super nasty is it escaped all radars until we deployed a cluster. So an actual cluster which had separate monitoring, right? So we found it indirectly by Zabbix, even though our profile showed it, we weren't really paying attention to it. So here's the sort of summary of it. The issue that we found is that we have, with 1.4 and 1.5, we have a crazy high number of IOPS going through etcd. If you have multi-master etcds, this will cause leader election failures on large clusters and bring down your whole cluster. So it failed on two fronts for us, and we found the root cause of it. The root cause is basically in 1.4, we have a bunch of quorum read additions that occurred. Now, a quorum read will force a write. So if you have a highly available cluster, it basically increases the writes that you had. And so right now, there's a ticket that I'll link to in the docs, or an issue. But we're going to have to sort of triage it and go through the different locations that are doing quorum reads and try to remove them where possible. And some things may need to be re-architected because of this. Oh, I don't hear you, Bob. I see your lips moving, but I don't hear you.
I'm having problems hitting buttons this morning. And so why didn't it show up before? I mean, you guys have been deploying for some time.
So the reason it didn't show up before is we don't have any upstream IOP tracking, and that needs to be done. America and I were talking about it. Like, we need to add a gate, because right now in a lot of the performance tests, we monitor CPU and memory profiles, but we need to add a gate for IOP profiles too on etcd. That's one thing that we can do proactively. The second thing is that we weren't paying as much attention on our side, even though we actually had the data. So it escaped us because we were, in many cases, we actually had machines and environments that were fast enough, right? But then all of a sudden, when somebody tried to deploy on Amazon with a limited IOP mount, then all of a sudden it punched up right away, right?
Can you give an example of some things that really require quorum read?
Oh, that was really hard to hear, Joe.
Sorry, can you give an example of some things that require quorum read?
So I can talk a little bit to the chain of events. Was quorum reads were off at the storage level, and there was a bunch of discussions from various people who were starting to run etcd in this mode, and they were like, well, we're seeing slightly weird things happen at big scale where ordering wasn't quite what we expect when one of the members starts to lag. Resyncs that drop something, kick it out, and then a couple of seconds later put it back in. And so the change was made in Core Cube to turn quorum reads on for everything by default. In OpenShift, we had never had quorum reads on from the very beginning, and we always ran HA. And there are like small flakes that occur when one of the members lags, but it was just never, like, in almost all the things, like it would cause like a flutter on something like a service, maybe briefly, which I think would impact, people when they're running at the extremes, but just not in the practical. And in OpenShift, we were only using quorum reads, and not even really quorum reads, but something even more sophisticated for authorization. When we push down an authorization token to etcd, we would wait until all the members confirm they had it, to prevent the classic grant access and then someone immediately uses that token and gets denied. So it was just not, it surfaces in extreme cases, not the normal cases.
So it sounds like it's one of those things where it was just super easy to use the quorum read thing and bugs go away, but the cost wasn't counted.
Yeah. And I'm scared too because they are very subtle, rare things. There is a risk, right, that we on both ends, which is we get small flakes and we go fix one thing, and we get a small flake if we turn Quorum Read off, we go fix it other places, then we get small flakes here and there. The list watchers are reasonably well set up for it, but the problem is that most of the controllers use the list watch and then do a series of calls based on it. And as they're round robining through, masters, they can trigger this because, they're not sticking to masters, or because, there's other delays going on in the cluster. So it was cropping up in hard to debug places. And so I think that's the trade-off risk.
I'm sorry, what was the trade-off? I was tracking you to the point where you said there was a trade-off here.
I mean, the trade-off is you give up some performance for not having weird edge case bugs happen.
Right. I think most people would probably take that trade-off.
Yeah, and that's what I worry about too, because I think we can relax it in some cases, but we don't have like we're not instrumented on the client side, on the server side, or on the etcd side to do like causal reads. And so like the vast majority of our controllers are single process causal read types of things, but we've not done any of the infrastructure work to do like, even the simplest, session style vector clocks or anything up and down the stack. And that's, a significant investment too. Like the simplest possible fix for the vast majority of these clients is a precondition on the etcd version. So the list watcher knows what resource version it's got for a particular resource, and it passes it down to the controller. The controller just automatically carries that through and passes that down to the API server. And the API server says, the resource version that this request gave me is stale. I'm just going to wait until I hit the resource version again. And we've talked about plumbing it, but it's a pretty big chunk of work.
And this will hit the client pretty hard in a place where the client is pretty unstable right now.
And it also, like, we'd have to start dealing with people who are using threaded clients a little bit more. Like the etcd client does a little bit of this for us, and there's maybe something we could turn on that, the etcd client can do this on the masters. That's one option, but it's not going to stop if the masters are talking to a lagging API server, and that's the thing that we would have to stop. So it really does have to go all the way up to the kube client and back down. And threaded, like, we're not using threaded, or there is no scenario today under which someone who's sharing a client across multiple Go routines is being impacted by, like, there's just no state that's shared. This would be like a, high water mark in the client. Probably we have to go through a couple rounds of tests to be sure that that's safe too. So, I mean, I don't know if anybody else has any other easy fixes. I mean, Tim, I think like when we had the off thing on the OpenShift side for create and then make sure that at least the members are up to date is a fairly easy thing to go do, like to take the code that we had before and move it into the storage layer. But that only helps some of these cases, and it doesn't help all the subtle issues.
I'd have to do it on a case-by-case basis, because like without knowing what the flakes are, other than, some people are not passing around resource version when they're trying to do some updates.
Yeah, no, this is, it's actually, what would happen is, like, so as an example, the one that actually triggered this was the kubelet. So the kubelet sync status manager is doing gets and updates in two different places, and the version coming from the watch would be one, and then we would go update the status, and the server would return us a resource version, and then we would use that for a subsequent get when we needed to fill out the most recent copy of the data for a couple of places. Mm-hmm. And so that data coming back came from a different master, and thus came from a trailing etcd on the read. And so the resource version for that was older than our high water mark, but we did propagate that through.
That seems, I mean, like on HA proxy, we specifically specified session affinity because we knew that when you hit the non-session one you were doing, you could potentially run into these issues, right? Like that was a hard requirement, and Daniel and I even chatted about this about, starting to have session affinity on all clients, right?
But that wouldn't, well, that helps until a leader change happens.
Yeah, but you're decreasing the probability from like 1 in 100 to 1 in 1,000, but you still have the case, you still have the edge.
Yeah, I mean, we're not doing load distribution on the API servers, so there is the case of today the masters are spraying more or less, I think. My understanding right now is that the masters are spraying to the underlying etcds fairly evenly. If we, once we turned on quorum reads, we were focusing on one particular master, or one particular etcd master. To get the benefit, we would also need to ensure that we didn't get hotspot. Like I would be a little worried about, turning on session affinity and rigorously enforcing it from the API server to etcd and putting in scenarios where we start hammering one of the etcds because all 4 of the masters, or however many there are, start talking to that. The API server start talking to one particular etcd. I guess it's no worse than it is today with talking to the leader. So.
I don't know if you guys noticed Joe's comments on the chat.
One other point here is that it's worth talking to the Google folks about Borg. I mean, Borg essentially is single master at a time, where the backups are just there for backups, and they just scale the size of the Borg master.
That's the same model that other things use too. The other masters are standby because it's only in this model where we have scale out API servers horizontally that this race condition occurs.
So actually I had one question on the shoot, I lost my train of thought. In etcd 3.2, I thought the rights were reduced. Is that the case?
I'd have to double check. I'd have to talk with Jiang. They're not on right now.
Because I thought this was like when they did the improvement for the serializable leads, I thought they were batching them, which they piggybacked on commit.
That was something that they talked about, yes. I mean, we could get much higher throughput on a single API server, if we really wanted to. We could also do things like windowed writes, short cycle windowed writes to etcd, because right now it's like a straight quit right through, right?
So the discussion that we had at the same time that this happened, so we discussed in OpenShift whether we wanted to patch it out. And one of the challenges would be we're actually giving up availability like this because the ability to do stale reads, even though it causes some weird consistency issues in some edge cases, means we can still lose the master and satisfy at least reads. You just can't satisfy writes. And Kube does not do well when you can't satisfy reads, but is fairly resilient in many cases to not being able to temporarily satisfy a write. And so, in the long run, even though I agree that it is easier just to turn on quorum reads or bump up IOPS, I do think having causal consistency at the client, as Joe was saying, over 2 or 3 versions, I would prefer to have causal consistency in the client and fix it that way. Just given our rough performance numbers, that's going to give us the best availability, or the best combination of availability and performance, because we can lean on the resource version fairly effectively.
The numbers that we have on API server today, because we haven't done it in a while, but the numbers we have today on API server on the load balance case is actually really good by comparison. We should probably do a single API server with backup standbys, and just to see what the performance characteristics are, do an A/B test for that model, because that's the traditional model. Honestly, it's only in Kubernetes that I've ever seen this model ever.
You're talking about changing the API server to the same master election model that the other controllers use?
Yes.
I don't know. The masters have to proxy exec and port forward. And so when we went through the first round of designs for this, we said, rather than creating two different scale out layers, we're just going to create one. And if we don't have, I mean, like, we can solve the causal consistency thing. Like, we've already started to do bits of it. So I don't know. I mean, I agree. Yes, it is simpler, but we're pushing a large amount of traffic through the masters. And I'd rather have one scale out master layer and have the controllers be master elected than have three different types: controllers, API server, and a scale out proxy layer. Because I mean, effectively the masters are supposed to be scale out proxy, and if we can't make them be effective scale out proxy, we should fix that. Like, for instance, defaulting to quorum reads on clients that don't opt into causal consistency is easy. And then adding causal consistency for controllers and standalone clients should also be fairly easy to make the default. And when we have that, at least we're in a scenario where, as long as you're not using two clients, which as far as I know, not a single component in Cube, that like all the controllers use a single client, Kubelet uses a single client, kubeproxy uses a single client. Like, you have to work to use two clients at the same time. I think that's fairly feasible to make happen. So I don't know. My bias is a little bit to not changing the API server model, but to just do the thing that scales and we at least understand how to fix.
But presumably, we still would need to make a recommendation for folks for 1.6.
Yeah, absolutely. I mean, who's running at this scale in the pure cube case who doesn't have the IOPS to spare? Probably not many.
Well, I think the bigger issue is just understanding. I think this is Joe's point from earlier, understanding that this causes a problem. So, I mean, just to make sure I understand the implication, you're running on Amazon. The recommendation would be, if you're running really big clusters, run your etcd instances on separate instances with high IOPS ELB, and put a monitor on the IOPS so that if you're ever hitting your IOPS limits, you're ringing big alarm bells that you need to go do something about it because weird things will happen.
Yeah, and turn on session affinity. It'll.
Yeah. This definitely crops up. So we started seeing this in small clusters on N1 standard 2 instances, because they were running out of we are seeing high IOPS. It is not blowing up those clusters, but some of those clusters are very IOP constrained, and 2 CPU instances are reasonable for small clusters, but I would expect bigger clusters to have much bigger IOPS provisioning for sure.
Is this, when you're saying IOPS, you're talking about the, again, this is kind of an Amazon-oriented question. You're talking about the disk IOPS or some more like system IOPS?
Disk IOPS for writes caused by the quorum read.
Right. Yeah, you were confusing me with the 2 CPU comment.
So on GCE, the quota for IOPS is a combination of size of disk and instance size, and so that's just. I've been debugging another problem we were having with Docker and device mapper on inversion, so I was momentarily crossing my scenarios.
No, we've run into the same thing where we've had to build these like informal tables with some help from the Google folks to understand
the docs are terrible. Yeah. I need a calculator.
Yeah.
So, I mean, I think we should bring this up with API machinery. Certainly, it's been on Dan and my radar for a little while, but we just haven't formally put it into anything. If 1.6, we left quorum reads on and bumped IOPS for those things, for most people, that's okay. For the specialized case for OpenShift, I do think we can probably survive it, but we'll probably make some different recommendations. And then, I mean, again, my preference is to just fix the causal consistency from the client. But if we want to take a broader discussion, I'll schedule a session in API machinery. We can argue that out.
I think that'd probably be worthwhile, because I'm still curious on the numbers of a single API server. I know that it's an exit strategy that gets you out of this pretty fast, and that allows you to still fix the other end in the long haul, right?
Yeah, I mean,
because we're not seeing terrible numbers out of the API server like we used to, right?
well, in the API server, I mean, there's like 3 or 4 more optimizations that that we've kind of punted around that could get us down even cheaper. So we're basically at the point where the controllers are the expensive bits. But if we have to, I mean, I don't know.
I mean, if you wanted to, you could just be even smarter, where you'd make sure you don't colo your controller. The way you have your HA set up, you just don't colo controller with API server. And if you do that, you're gonna not hit the same. You won't compound the profiles, right?
Yeah,
It won't be superpositioning.
yeah, and the controllers right now, the controller manager is fairly easy to chunk into smaller subgroups if somebody wanted it. Like even as we get the number of shared caches down, so we still got like a 3 to 4 cache duplication layer. Most of Andy's work for that will go in 1.6, 1.7. We should be down to single, 1 or 2 replication factors for the various informers and list watchers, which once that's in place, like splitting out the controllers causes more traffic to the API server, but less traffic to the thing. I mean, the nodes still are going to be the biggest single client. And I think if we're going to say we want to scale to large numbers of nodes, at some point, we can keep optimizing the API servers for number of nodes, but I would prefer to be able to scale API servers independently of number of nodes, or scale API servers with the number of nodes rather than have to do expensive optimizations. And it feels like right now, like, I mean, Wojtek, I don't know what your opinion is on this with the update status changes, but say we get this performance improvement in update on node condition status tracking. What's the next update? Is pod status update lurking behind node status update as a significant cause of cluster load in KubeArk?
So it depends like on the load. We have reasonably or maybe unreasonably low throughput in our tests. It's like, I think we are generating roughly 10 to 20 like pod deletions and or creations or changes. So like changes from node status changes coming from node objects are like order of magnitude more of them. So
I'll say that in some of our very dense customer environments, some customers who are on older versions are starting to get into the 100 update a second clusters from all the different participants, and like they don't even have half the optimizations that we've put. But if status updates are coming somewhat frequently, like pod status would be like a gut next check. I feel like, I guess my gut feeling is that I still would like to preserve API server scale out, just because it's the easy hatch for if node updates are crushing the cluster or pod status updates, and we want to go from a 500 node cluster to a 1,000 node cluster, if we want to go to a 500 node cluster with 10 pod density to 20 pod density, in both of those cases, number of updates from the nodes is going to double roughly, and being able to throw more API servers at it is very nice.
I agree, yes.
But I mean, again, I'm open to OpenShift bundles more things with the API server masters, like the OAuth servers, and so we're somewhat biased towards we have a higher workload on the masters, and I think from a DEX perspective, if you've got lots and lots and lots and lots of tenants, you start crushing you start hitting your login servers more often. For anybody who can offload all their authentication off the cluster like GKE, not as much of an issue, but for anybody who's got a dense multi-tenant cluster, I do think at some point, OAuth needs to scale independently, so it's not the end of the world to say, maybe on our side, we're doing too much in our masters and we can tolerate going back down to 1. I mean, Joe, on the exec Bastion proxy thing, I mean, we have port forward and exec today, both of which could be extremely bandwidth limited. I think there's a scale point at which you do want to scale bastions independently. I don't think most people have even come close to hitting that scale point, which is why I worry about creating another type of thing for that in the near term.
Well, I was playing around with ngrok. Have you looked at ngrok? It's essentially like a forwarding thing that skyhooks off of a cloud server for getting access to stuff. And so something like that is just fundamentally distributed, right? Where you're just running another job that exposes this in a different way through a different path.
Well, and you give root access to all those processes everywhere on the cluster too.
I'm confused.
Well, I mean, we don't, this is a pretty common thing we have, but we don't run anything that has access to anything higher than node level privilege on anything except a very restricted set of nodes, just because any kind of proxy running on the cluster that is a man in the middle to the nodes and is given authority to talk to the nodes to do exec or port forward, has to get some credential, or we have to do a handoff one time.
I guess what I'm trying to say is that you don't have to run these things as a shared service. It can actually be per namespace, per job. When you want to port forward something, launch a specific job for port forwarding that thing, and then have it use some other resources that just are scalable network, bastion type stuff, right? So it's a different architecture. It's a red herring right now. Let's not worry about it.
Yeah.
I do worry about putting so much stuff through the API server there. It feels like it is a little bit.
Yeah.
It's a little bit tightly coupled, but it's definitely not the top of the list in my mind.
Yeah, and it was kind of the original design discussions. I think we actually talked about bringing up. This was before node ports even existed, and before we had the changes in the CRI to offload exec and port forward to something that's even resource constrained versus just the Docker daemon. When we went through that kind of stuff, it was how many different complex pieces do we want to run as the edge layer, and trying to get that number down to 2 or 3 things was kind of the overriding concern to keep the complexity of topology low. And so I agree, we probably want to start considering that now that we have actually split out, or now that we are in the process of splitting out exec in the CRI, to actually not be going through the kubelet and going through the Docker daemon.
And I think when you say that the API server is really a bastion, the thing that worries me about that is that you generally don't give your bastion permissions. In the AWS case, we're giving it essentially root on AWS through the AIM role so they can do the cloud provider. So getting the cloud provider separated out onto separate nodes that are not the API server is also a big step in the right direction here, because now the API server is, but at the end of the day, it has write privileges then into the etcd, which is essentially root 2. So it's I have a hard time seeing the API server as a true bastion.
Yeah, I mean, it has to man in the middle all of the traffic for the cluster. And so where we don't have better, less privileged man in the middles, I don't want to add new man in the middles, I guess.
Well, so I don't think it necessarily has to man in the middle all traffic to the cluster, right? I think just like we have
it has to do authentication and authorization, which today means that it can make decisions arbitrarily about who can write what, and all you have to do is be able to write to a pod arbitrarily, and the cluster is yours.
Okay. So let me be concrete here. What if we had a system that was like Ingress, but it was actually focused for doing port forwarding and something like that? So essentially use the API server to program that thing, and then that thing essentially does the magic.
Yeah, no, I think that was one of the original proposals for exec and port forward. Once we have something like that works on all the cloud providers in Metal, I would absolutely prefer to move exec and port forward out. Yeah.
And it doesn't have to be a either or, right? I mean, yeah, but again, not top of the list.
So rewinding back, I'll schedule a discussion in API machinery to talk about the causal consistency issues and what we could potentially do. And Tim and Joe and everybody else on the call who cares about that, I'll send the invite to both SIGs.
That sounds good. And it would be worthwhile to have some sort of doc that lays out this space, because I think this is the type of discussion that can easily get wound around itself just deciding what the hell we're talking about.
Yeah.
Yep.
Clayton, do you want to make a point of mentioning the ticket or possible impacts on 1.6 in the main meeting, or you think it's?
I think if Tim wants to bring that up and talk about, we should definitely tell people that if they weren't if they weren't looking at IOPS on their clusters, they should do that calculation. Hey, are you okay with tripling or quadrupling the amount of IOPS that you push through your etcd instances? Yes or no?
I think it's definitely worth a heads up in the main meeting.
Well, yeah, it's more than that too, because like you can, if you're not careful, you can totally hose your cluster. So, as a side point, I do think that we should have gating on upstream. We need to start adding more tests so that we can monitor this, because it blindsided us. And I think if we have some more tests that validate what we're actually any drift in performance outside of just the standard CPU and memory, so that way we can track it over time.
Yeah, I think I agree with the larger point that quorum reads are a expensive, heavy thing that we need to track, and we should do that. Or IOPS, which is what quorum reads turn into, but regardless.
Well, we're out of time for today. Tim, I did want to do a quick follow-up. There was one of the things that we got tasked with that we discussed last meeting was going through the etcd. I think it was the etcd ticket feature checkoff list.
Yeah, I haven't done that. I've been on bug hunt.
Okay. Well, consider yourself nagged.
Okay.
Anything else? Anything else for today?
Nope.
All right. Good discussion. See everyone in the main meeting. Thanks.
Happy Thursday. Yay.